Okay, we'll be doing spring element theory, which is a displacement method. The main goal here is to determine the global stiffness and nodal displacement and the forces on the spring I think I should just start straight to the example. No, I have to explain something before we do an example. So let's say we have a spring like this. Let's say we're doing what? A spring. We're doing a spring element. Sure. Just we're doing a spring element. Okay, so here under spring element is gonna be a 1D, a one-dimension spring element. So let's say we have a spring like this. Okay, and then we have forces acting this way. Let's say we have force, and then we have another force acting the other direction. Okay, like this. And then let's say this one is our K, like this. And then let's say we have a spring here. This is our direction, x is equals to 0. Let's say we have a spring here, and then we have a distance from here. Let's say it's going to be our x1, and then a distance from here to there. Let's say it's going to be our x2. And then now, if we apply a force to this spring, let's say it's going to move a distance, maybe let's say from here to here. If we apply a force, let's say this one is going to be undeformed, and then this one is going to be deformed when we apply the force. And then we're going to have a distance again from here to here. Let's say it's going to be our x1 prime. Okay, and then a distance from here to there. Let's say it's going to be our x2 prime. Okay, so this one is going to be our deformed, this one, the one that have a prime, is going to be a deformed spring. Okay, so we all know that the formula of spring, the force, it's F is equals to K multiplied by length. So here our length is going to be the distance between x1, x2, x1 prime and x2 prime. Okay, so let's say this one is going to be our length, and then this one, the second one, is going to be our L prime. Okay, so in these two springs we're going to have K into L prime minus L. Okay, L prime minus L. So therefore we're going to have K into the L prime. On the L prime, we're going to have the x2 prime and the x2 from these two springs. Okay, so this this L prime and the normal L is going to give us what? The nodal displacement. Here I just want to show you how this nodal displacement coming from. Okay, from this spring when we have a normal spring, and then when we expand it in a certain distance. So here we're going to have K into the x2 prime minus x2. Okay, and then we're also going to have the negative from this negative L, negative K into x1 prime minus x1, like this. Okay, so guys, when we write the nodal displacement, we write it like this: U equals to x prime minus x. So this one, we call it what? A nodal displacement. Nodal displacement. We call it nodal displacement. Okay, so therefore we're going to have KU2 minus KU1, because you can see our U is equals to x prime minus x. Okay, x prime minus x. Therefore we're going to have K multiplied by U2, since it's 2 here, and then minus K multiplied by U1. Okay, so this equation is going to help us to determine the global stiffness, the nodal displacement, and the reaction forces on the node of the spring. So guys, these points here, these points, we call them nodal displacement. We call them nodal displacement. It's U, okay? It's U. Sharp. So moving forward, our force here, let's say this one's going to be our force 1 and then this one's going to be our force 2. So which means our force 1 is going to be moving to the left, which is going to be a negative force. And then the F2 is moving to the right, which is going to be what? A positive force. So this is what I'm saying. So F1, our F1 is going to be negative F, okay, and then our F2 is going to be a positive F, okay. And remember, our F from here is going to be our F here, remember, it's K into x2 minus x2, x2 prime minus x2, which means this x prime 2, we can write it as u2, okay? And then this x1 prime, we can write it as what? As u1. So therefore, our force is going to be F is equals to K u2 minus K u1, okay, from the nodal displacement x prime minus x, okay. It's u here. Minus u2, like this. And then now we have F1. Our F1 is equals to negative F, and then our F2 is equals to the positive F, okay. So which means we're going to have F1 as K as negative. Remember, our F is this one. It's KU2 minus KU1. So it's going to be negative. Sorry, let me just write it clearly. So it's going to be negative into KU2 minus KU1. Okay. And then our F2 is going to be a positive F, which is going to be KU2 minus KU1. Okay, like this. And then now we can just multiply it, and then we're going to have a KU1, the positive one, and then we're going to take the negative one to the other side. It's still going to be the same thing if we say negative KU2 plus KU1. I just want the negative to be on the other side. So we're going to have something like this. Our F1 and our F2, we have F1 and F2. And then from here, we can write these two equations in a matrix form. So the moment we're talking about the spring element, we're going to use what? The matrix. Everything we do in finite element analysis, okay, it's based on a matrix equation. So we're gonna do a matrix form all the time. When we're doing this type of questions, we're gonna be using a matrix form. So to write these two equations in a matrix form, we're gonna have F1 and then F2 all equals to, and then we're gonna open two brackets, and then we're going to have the positive K and negative K, and the negative K and the K here. And then on the side, we're going to have the nodal displacement, which is going to be U1 and U2. So this is how we write our matrix. So this is our, what do we call? We call it a stiffness matrix. This is our stiffness matrix. K into K minus K minus K, K. Okay, we can also, if this whole thing is from here, we have 1 minus 1 minus 1 1, like this. So the K multiply this 1 and negative 1, and then we get the positive and the negative, negative and the positive, like this. So this is how we write the matrix form. So all the time we're going to do what? We're going to use what we call a matrix equation. Everything we do in a finite element analysis, okay guys, please note this down. Everything that we do on a finite element analysis is based on a matrix equation. So this matrix equation, we can also write it in short like this. Let me just erase this part. We can also write it like this as a short equation. K, this big letter K, it shows that is what is a stiffness matrix, and then we have the nodal displacement. This U is an overall displacement. It's an overall displacement. Okay, we call it an overall displacement vector. It's a overall displacement vector. U, it's overall displacement vector. I will write it on the other side. It's overall displacement. Okay, so now I want us to do an example, but here on this example, I'm not gonna write the values. I was just gonna do example with the variables. So let's say we have two springs connected to each other. So let's say we have two springs. We have two springs connected to each other like this. Let's say here we have a node. Okay, we have two springs connected to each other and also connected to a wall. Let's say this one, it's connected to a wall. Okay, it's connected to a wall, and then we have the node. We have the node here. We also have a force moving to the right. Let's say our force is P, and then we have K1, and then we have K2 here. Okay, and then where I mark with the dots, these ones, we call them a nodal displacement. So we're gonna have node 1, node 2, okay, and then node 3, like this. Okay, so it's connected to the wall. This is the wall. Okay, end of the wall. We're gonna have some loading, this P at the end, which we'll call it force P. Okay, and then now for our system, we're going to have 3 nodes. This is the nodes 1, 2, 3. Okay, and 2 elements. When I say 2 elements, I'm talking about the springs. So this one's gonna be our first element, and then this one's gonna be our second element. Okay, when I say element, just in your mind, just know, okay, when we're talking about element, we're talking about the spring here from node 1 to node 2, it's element 1, and then from node 2 to 3, it's element 2. Okay, guys, so sometimes you can be given 3 elements, 4 elements. It depends. They can give you any elements, okay, so that you can determine the global stiffness, you can determine the nodal displacement, you can also determine the force on the spring. Okay, so we have this. So the first step to determine the global stiffness, the main reason here, remember, is to determine what? The global stiffness, K, the big letter K. So to determine that global stiffness, we're going to follow these steps. Okay, so the first step is to split up our system into individual elements. So we're gonna split element 1, and then we're also gonna split element 2. Okay, so number 1, we're gonna split up our system into individual element. So the first step is to split. Okay, is to split individual element. So we're going to have element 1 like this. Okay, so remember, we have the force here, which is moving to the right. So we're going to have something like this. Okay, remember, this is our first element. We have node 1, we have node 2 here. Okay, and then K1. Okay, so we're going to split these elements, our first element and then second element. We're going to have something like this, K2, and then we have the node, and then another node. So you see here the 2 is between K1 and K2, which means here we're also gonna have node 2, and then here we're gonna have node 3. Okay, and then we have the forces moving to the right. We have the forces moving to the right. Okay, this is our first step. We have to split 2 elements. Okay, and then for each element we are going to have force vector. We're going to have the stiffness matrix and a displacement vector. Okay, so this is the displacement, and then this is the forces. The arrows that are moving to the right are the forces, and the 1 to 2 are the displacements, and then we have the stiffness matrix. We have the stiffness, which is K1. Okay, and then from them we're gonna write element 1 matrix and then also element 2 matrix. Okay, so which means here is going to be, so here is going to be our F1, and then here is going to be our F2, and then F2 here, and then F3 here. Okay, so we write these forces according to what? According to the nodal. Okay, according to the nodal displacement. So we have 1 here, we're going to have F1. We have 2, going to have F2. We have 2 here, we're also going to have what? F2, 3, and then F3. So after here we're going to write this in a matrix form. Okay, we're going to write this in a matrix form. To write this in a matrix form, we just open 2 brackets. We're going to start with the first element. So we have F1 and F2. We're just going to write F1 and then F2 like this. Okay, and then we can just write prime 1 to the power 1 to show that we're dealing with what? With the element 1. So when we write for element 2, we're going to write 2 at the top, okay, as an exponent. Okay, all equals to, and then we open bracket. So we have K1. Remember, when we write our matrix, we write it as K1 minus K1, and then minus K1, and then K. Okay, and K. And then we're gonna check our points. We have 1 and 2, which means we're going to have U1 and U2 like this. Okay, so this is how we write the matrix for what? For first element. Now let's write for the second element. For the second element,
Chaza, can you please repeat this step? What step? You said, what did you say about this step? What are we supposed to do?
Which one? The matrix 1.
Yeah.
Okay.
So this is step 2, right?
Yeah. Sure.
The first step is to split.
Yeah. Okay. Let's say this.
You don't have to put it there, but yeah, I didn't hear you nicely.
Okay. No, we're still on step 1, guys. Step 1, we have to split it, and then after splitting it, we're going to what? To do the matrix. And then step 2, that's I'll come to step 2. We're still on step 1. I'll write, okay, our step 2 is this one. We're still on step 1. Okay, so step 1 is splitting the elements. This is how we split it. Okay, and then we write the matrix form. We're still on step 1. Note, okay, Kuriso, sharp. So we're still on step 1, and then this is our first matrix for element 1. Okay, it's gonna look like this: K1 minus K1 minus K1 K1. Okay, and then we have node 1, node 2, which is U1 and U2. Now let's focus on second element. So let's do second element, where we have something like this. We have F2 and then F3. We have the node 2 and then another node 3 and then K2. Okay, K2, which is element 2. This is our element 2 here. F2 here. Okay, so here our matrix is gonna be F2 and then F3. Okay, like this, and then global stiffness is gonna be K2 minus K2 minus K2 and then K2, and then on displacement we have 2 and 3. We have 2 and 3, so we're going to have U2 and U3 like this. Okay, so we are done with the first step. First step, we have to split the elements and then we write them in a matrix form. Okay, and then number 2, step 2. Now we're coming to step 2, where we're going to what? To combine these two systems. We're going to combine element 1 and element 2. Matrix of element 1 and matrix of element 2. We're going to combine these two systems of equation together so that we can calculate what? A solution for the overall system. Okay, so we're going to combine. Step 2 is to combine. We combine two systems. Okay, it will depend. Sometimes you're gonna have 2 elements, sometimes you're gonna have 3 elements. So if we have 3, we're going to combine 3, because now we have 2. Let's say we're going to combine these two system of equation together. We're gonna combine 2 system. Okay, if it's 3, we're gonna say 3 system. Okay, we're gonna combine 2 system. Going to combine the system of equation. Actually, let me say combine 2 system of matrix. Okay, so in order to do that, we're going to use a shorthand that we defined in the previous slide, where I say we have F into K and then U, and then remember I said U is what? It's an overall displacement vector. Okay, so we're going to have this one for F1, okay, and then for element 1, and then we're going to have this for element 2, okay, for element 2. The 2 here shows that we're dealing with the element 2. So going ahead, we're going to write this out using the overall displacement. This is the overall displacement, the U. Okay, and then now the overall displacement is going to have like 3 displacement. Okay, since we have 3 nodes, 1 2 3, we have 1 2 3, which means our matrix is going to be a 3 by 3 matrix. Okay, it's going to be a 3 by 3 matrix when we combine what? 2 system. Going to have 3 by 3. Okay, to see that is a 3 by 3 matrix, you just check on your system or how many nodes do you have. Okay, we have 1 2 3, which means at the end we're going to have a 3 by 3 matrix. Okay, we're going to have 3 by 3 matrix. So how we're going to write this matrix? Remember, we're going to combine the element 2 and element 1. So now let's move forward, and then I'll just write this one down. We have F1. We also have F2 like this, where we had K1 minus K2. This is K1. And then we also had K2 minus K2 minus K2. U2, U3, F2, F3. Okay, so now we're going to combine these two. But we're going to have a 3 by 3 matrix. Okay, so we're going to have a 3 by 3 matrix. So we're going to have U1, U2, and then U3 on the horizontal like this. Okay, oh, this is small, sorry. So we're going to have U1, U2, U3. Guys, when you come here on the second step, when we're adding, you check your nodal, you count your nodal. Okay, how many nodals do I have when it comes to combining? Which means we're going to have what? A 3 by 3 matrix, because you have 3 nodals. If we had 4 nodals, which means here when we're combining, we're going to have a 4 by 4 matrix. If we're 5, we're going to have a 5 by 5 matrix. Guys, are you following? Just raise your hand and then we'll move if you're following. Okay, sharp. And then here we're going to have a 3 by 3 Then I'm just gonna write u1, u2 this side, u3, like this, just to understand it better. So this side we're going to have forces, okay? This side we're going to have what we call forces. I think, yeah, we're going to have forces. Okay, we're gonna start with the first one and then we're gonna go to the second one. Okay, so the first one, we have u1 and u2. We have u1 and u2, which means we don't have u3. So at u3 we're going to have zeros. All the u3 we're going to have zeros, like this. Wherever there is u3 vertically and horizontally, we're going to have a 0 0. Do you have any question?
Can you repeat that?
Okay, we are starting with the first element. Remember I said when we're combining here, we check how many nodals do we have. Okay, we check how many nodals do we have. We have 3 nodals, so we're gonna check on our first element. We write 3 nodals, like u1, u2, u3. Okay, and then on our first element we don't have u3, we only have u1 and u2. So wherever there's u3, we're going to write zeros. Okay, we just want to get the equation of global stiffness. To get the global stiffness, and since we have 3 nodals, we have to introduce this u3, okay, from our first element. So wherever there's u3, since at our first element we don't have u3, we write zeros. Okay, and then now we come here at u1. So remember, here is gonna be u1 and then here is gonna be u2. Okay, like this. So when we write this what do you call this matrix, 3 by 3 matrix, we're gonna check. We say u1 matches with u1. Okay, so this is our u1 and then another u1, it's here, which means our u1 and u1 is gonna be what? It's gonna be k1 here. u1 and u1, like this, like this. So we're gonna, this is our u1 and then this is also our u1, so it's gonna be k1. Okay, and then u2, our u1 and u2, we're gonna check which one, where is u1 and u2. So this is our u1 and then u2 is here. So our u1, u2 is what? Is negative k1. Okay, it's gonna be a negative k1. And then now let's focus on u2. u2 goes with u1. We check u2 and u1, which is what? Which is negative k1. Okay, u2 and u2 is what? It's positive k2, like this. So this part is for the first element too. Sorry, we have f1, f2, we don't have f3, so it's gonna be 0. Okay, because now at element 1 it's 1 and 2, it's 1 and 2, we don't have 3, so we're going to have something like this. Okay, do you have any question, guys? f1, like this. And now this is our 3 by 3 matrix for the first element, and then for the second element we're still gonna do the same, but here we're going to have let me just write here and then use a different color. Okay, here on the second element we're going to have u1, u2, u3, and then u1 on the side, u2, u3, like this. Okay, and then we check here on our second element we have 2 and 3, but we don't have 1. So wherever there's u1, we're going to have 0 0, because we don't have u1 on our second element. Okay, so u1 it's here, it's going to be 0 0, like this. Okay, and then we don't have f1, so which means it's going to be 0, and then we're going to have f2 and then f3. Okay, f3, and then now we go to our second element, this element here, and then we check u1 and u1. We don't have u1 and u1 is 0, that's why we have 0 here. u1 and u2, we don't have u1 and u2 is 0. u1 and u3, we don't have u1 and u3. We have 2 and 3 only here, so that's why I said at u1 it's gonna be 0. And now let's come to u2 and u2. This u2 and u2, we're gonna check our u2. Remember here it's gonna be u2, and then here it's gonna be u3. So it's gonna be u2 and u2, which is k2. So we're gonna have k2 here, and then u2 and u3, which is negative k2. Okay, and then now let's come to u3 and u3 and u2. So u3 and u2 is it's negative k2. Okay, and then u3 and u3, which is k2. Okay, and then now we have a 3 by 3 matrix. Remember, the 3 by 3 matrix is from our nodal. We have 3 nodals, that's why we are writing this matrix in 3 by 3. Okay, so that's the reason why we're writing 3 by 3, because we have 3 nodals. So this is our second step, guys. So from here, we're still on the second step. From here, that's where we're going to add this 3 by 3 matrix. Okay, we're going to add this 3 by 3 matrix. So we're going to say f1 plus f1, which is going to be f1 plus 0, which is going to give us f1. Okay, let me move forward. So when we're adding, we're going to add element 1 and element 2, element 1 plus element 2. So we're going to say this f1 plus this f1, so it's f1 plus 0, which is gonna be which is gonna be f. So we're going to have f here, f1. Okay, and then now let's go back again and then add f2 and f2. So remember, we're combining the 2, so it's gonna be f2 plus f2. Remember, this one is gonna be f2 1, and then this one's gonna be f2 to the power of 2 to show that is it's element 2. Okay, so even this one is gonna be to the power of 1, and then this one's gonna be to the power of 2. Okay, so now we're moving forward. It's gonna be f prime 1 2 and then plus f2. Okay, so it's gonna be
Oh no, I can see now.
Okay, so it's gonna be f2 1 plus f2 2 for element 2. Remember, we're combining 2 elements. And then now let's move forward, and then we're going to add f3 plus f3. So it's gonna be 0 plus f3. So it's gonna give us f3. So it's gonna be f3 here 2, or equals to, remember, we're going to have 3 matrix. We have u1, u2, u3. Okay, u3, and then u1, u2, u3. So what are we going to do now? We're going back to our matrix and then combine the 2, okay? So we're going to say, okay, we're going to check u1 and u1 on our first element. Remember, this one is our first element, and then this one is our second element. So u1 and u1 here on our first element is k1, and then on our first element u1 and u1 it's k1, and then here on our second element u1 and u1 is 0. So it's going to be k1 plus 0. So u1 and u1, when we combine them, it's going to be it's going to be k1. So here under u1 and u1, we're going to have k1. Okay, and then now we go back again to our matrix. We combine u1 and u2. Okay, u1 and u2. So u1 and u2 on the first matrix is is negative k1, and then on our second element is 0. So it's going to be negative k1 plus 0. Okay, negative k1 plus 0. Guys, are you following? Do you have any question? Are you getting this? Okay, sharp. So it's going to be u1, u2, u1, u2. So it's going to be negative k1 plus 0, which is going to be what? A negative k1. And then 0 plus 0 for u1 and u3 is going to be 0. Okay, so we're going to have a negative k1 here under u1 and u2, a negative k1, and then here's going to be 0. Okay, if you are getting this, let me just write the values here. So u1 and u2, u2 and u1, we're going to have a negative k1 here. Okay, and then u2 and u2, we're going to have k1 plus k2, k1 plus k2. Okay, just let me just show you u2 and u2, u1 and u2. Okay, so this is what I'm saying. So now we're focusing on what? On u2, u1, u1 is 0 here, and then u1 is negative k1. So negative k1 plus 0 is going to be negative k1. Okay, and then u2 and u2. On u2 here, it's this one, and then u2 and u2 is this one. So it's going to be k1. This is 1, guys. Okay, k1 plus k2. That's why I wrote k1 plus k2. And then here on u2 and u3 is going to be 0 plus negative k2, which is going to be negative k2. And then so u3 and u1 plus u3 plus u1. So it's going to be 0 plus 0. And then here it's going to be 0 plus negative k2. And then here it's going to be 0 plus k2. So if you get this one, you'll be sorted. If you know how to combine 2 elements or 3 elements, so you'll be fine. If just know how to combine these two, just check by u1 and u1 and u2, u1 and u3, u2 u1, u2 u2, u3 u3. I mean u2 u3. So that's how we combine them. So we're gonna have k2 here. Okay, and then here we're going to have 0, negative k2, and then here we're going to have k2. Okay, guys, after writing, actually let me show you this part, the one that I'm doing with red, we call it a global stiffness. When they say determine global stiffness, this is what you do. So global stiffness, we're gonna write it like this: a big letter K into, it's gonna be K1 minus K1 0 minus K1 plus K2. Okay, and then minus K2, and then 0 minus K2, or like this: U1, U2, U3. So this one, we call it what? A global stiffness. Okay, when they say determine global stiffness, just know, okay, it's the combination of element. It's gonna be element 1 plus element 2. That's what we call what? A global stiffness. You can just write it like this. Okay, we can write it like this. This is a global stiffness. We write global stiffness like this. And then moving forward, we're going to have, I just want you to note this. Let me just go back a little bit. Yeah, here. Let me just go back here. So you see here, we have a wall here at node 1. We have a wall at node 1, and then we have another node here at 2. We have a force at node 3. Okay, this is force P moving to the right. So here at node 1, note that we have a wall. So I just want to write this node down. If we have a wall, sorry, Sheza, what are you doing? Sorry guys. So you have to note this down. Node 1, you see at node 1 we had a wall. So node 1 is connected to the wall, which is going to be moving. So that means the displacement there at node 1 is 0. Okay, so node 1 node 1 is connected to what? To a wall. To the wall. Therefore, I was saying node 1 is connected to the wall. It's not going to move, like it's not going to move at all. So that means the displacement there at node 1 is what? Is 0. So our u1 is gonna be 0, because it's what? The node 1 is connected to the wall, which is not going to what? To move. It's not going to move at all. So I was saying it's not going to move, so therefore u1 is equals to 0. Okay, and then f3, you see node 3 there, we have a force, we have force P, which means our f3 element 2 is going to be equals to what? To force P, okay? It's going to be equals to force P. And then node 2, remember node 2, we have two forces at node 2. We have two forces, the one for element 1 and the other one for element 2. So node 2, node 2, we have two forces which is applied in a overall. So the sum of these two forces is going to be 0, okay, because there's no external force being applied. So this is what I'm saying, f21 plus f22 is going to be 0, because we don't have what? An external force being applied. Okay, we don't have an external force applied. So this is what you have to know, to note from that object, okay, from that system where we have two springs. So this is what I was saying here. u1 here, u1 is equals to 0, and then f2 is also equals to 0, and then f3 equals to what? It's equals to P. Okay, here why we said f2 is equals to 0 is because there's no external force being applied. Okay, so from our what do we call our matrix here, from here, this is our matrix, which means we can get what? The equation. So from getting the equation, that's where we can determine what? We can determine the nodal displacement. We can also determine the force. Okay, so what we're going to do, we're going to have f1 is equals to what? k1 u1 negative k1 u2, and then here it's gonna be 0, and then here, remember, this one is 0, and then also u1 is 0, and then this one also is 0. So if it's 0, let me just cancel this line before I explain a lot.
So Cheta, the force only is only applied at what do you call node 3 by element 2?
Yes, node 3. Yes.
Okay.
Yes, it's here.
But when we split the when you split the systems, we still need to show that this force is being applied there.
Yes. Remember, it's pulling, so which means there will be other forces going with it. Okay.
All right.
Yeah, so here I was still explaining that u1, remember, is connected to the wall. We said 0, and then f2 plus f2 is going to be 0 because there's no external force applied. Okay, so this one's going to be 0, and then also this one's going to be 0, and then also this one's going to be 0. If we have the 0 here, which means the whole part here at u1 it's gonna be 0 like this. This one's gonna be 0. Okay, even this one's gonna be 0, which means we're gonna be left with what? With these two. Okay, but before we move forward, let me not do this. Okay, now I said f2 plus f2 is gonna be 0, and then u1 is gonna be also 0 because it's connected to what? To the wall. Okay, from here we can just write equation from this matrix. We can write equation from this matrix. So our first equation is gonna be f1. It's gonna be f1 is equals to k1 multiplied by u1. Even though we know that our u1 is 0, we just want the equation. And then now it's going to be f1 is equals to k1 multiplied by u1 negative k1 multiplied by u2, and then 0 multiplied by u3. And then the second equation is going to be 0 is equals to negative k1. The second equation is going to be negative k1 times u1, k1 plus k2 times u2, and then negative k2 times u3. So and then the third equation is going to be f3 is equals to 0 multiplied by u1, negative k2 multiplied by u2, k2 multiplied by u3. Okay, so now let's write the equation. Okay, so we're going to have f1 equals to where is it? u1 is going to be k1 u1. We all know that u1 is what? Is 0. Okay, we're gonna substitute that. So it's gonna be k1 times u1 minus k1 u2. Okay, and then there by u3 is 0 because it's gonna be 0 multiplied by u3, which is gonna be 0. This is our first equation. And our second equation, we said f2 plus f2 is going to be 0. So it's going to be 0 equals to negative k1 u1. Okay, and then k1 plus k2 multiplied by u2 plus k1 plus k2 all multiplied by u2. I was supposed to write in the other way around. This is all multiplied by what? By u2. And then u3 is going to be negative k2 u3. Okay, guys, this equation is from the matrix. And then f3, we said f3 is equals to p, so we can just write it as p equals to it's going to be 0 plus negative k2. Let me just write negative. It's going to be negative k2 u2, okay, and then plus k2 u3. These equations, they are from the matrix. Okay, so now we know that our u1 is 0, so which means the first equation is going to be, this one is going to be cancelled since u1 is 0. Okay, so we're going to have f1 or equals to negative k1 u2 like this plus 0. Okay, and then the second equation is going to be, remember, u1 is 0, so we're going to have k1 plus k2 u2, and then we have minus k2 u3. Okay, k1 plus k2 u2 minus k2 u3. Okay, and then the last one is going to be p equals to, and then it's going to be negative k2 u2 plus k2 u3. Negative k2 u2 plus K2, U3, like this. Okay, and then from this equation, we can solve for U2, U2, and U3. And then we call them what? A nodal displacement. We call them what? Nodal displacement. We can also calculate the value of what? Of F after getting what? The nodal displacement. Okay, guys? So here we can just say this is our first equation, and then this is our second, and then this one is our third equation. And then we use simultaneous equation and solve for U2 and U3. We can also solve for F1 after getting the value of U2, because we'll be given the value of what? Of K1. So now let's do an example where we have the values. Now we have the values. Okay, so we're gonna do example from the notes. We were given 3 springs, I think. Wait, where is it? I can't see it. Oh, it's here. So we're gonna do example from the notes. So we are given a springs, and it's connected to the wall. We have a spring here, we have another spring, we have another spring here, and then we have a wall at the end here. We have another wall here, and then the say here is gonna be here. It's what? It's node 1, okay? And then here in between, it's node 3, and then here in between, it's gonna be node 4, and then here it's gonna be 2, node 2, okay? Node 2. Guys, the nodes, they can just name nodes any number. It can be 1 3 4 2, can be 1 2 3 4. They can just name any they can just name node with any number. Okay, so the first K1, the first K is equals to 200 Newton millimeter. So we have 200, and then the second one, it's 400, K2. We have 400, okay? And then K3 we have 600. This is from example. Okay, we have 600, okay? And then here at node 4, we have the force. At here, we have a force, okay, which is what? P. And then P, it's equals to what? It's equals to 25 kilonewton. The P, which is force, which is equals to 25 kilonewton. Okay, remember the first step is to split the elements, Let's hope I didn't left anything. So we're going to have element 1, element 2, element 2, and then element 3. So here we're going to have 3 elements. Okay, we're going to have 3 elements. We have wall on our node 1 and wall on node 2. So the first question, they want us to determine what we call the global stiffness. Okay, so to determine the global stiffness, it's going to be the big letter K. It's equals to K1 for element 1 plus K2 for element 2 plus K3 for element 3. Okay, like this. So to determine this K1, K2, K3, we have to write it in what? In a matrix form. Remember, the first step is to split the elements. So we're going to have this element 1, which is 200, okay, where we have 1 and 3, okay, 1 and 3. Okay, and then element 2, remember we have the forces. Force is moving to the right, so we have the forces. Okay, it's gonna be F1 and then F3. Okay, like this, sharp. And then for element 2, we're going to have this. For element 2, we're going to have 3 and 4. Okay, because it's between 3 and 4, element 2, which is what? Which is 400. And then element 3, we're going to have something like this, where we have the 600. Guys, remember there are forces here. We have the forces, which is gonna be F3 and then F4. Okay, and then here element 3 is between 4 and 2. It's between 4 and 2. Okay, here we have the forces. So this is our element 3. And then to write stiffness matrix, it's gonna be like this: K into 1 minus 1 minus 1 1, like this. So it's gonna be 200 multiplied by 1, 200 multiplied by negative 1. So we're going to have the metric stiffness for element 1, the matrix for element 2, matrix for element 3. So we have 200, we have 400, we have 600. Now let's write the K1, K2, K3, and then after that we're gonna add them together. We're gonna add them so that we can get what? Global stiffness. To get what? Global stiffness. Remember, we have the nodal 1, nodal 3, nodal 3, nodal 4, nodal 4, nodal 2. So just remember, element 1, it goes with 1 and 3. Element 2, it goes with 3 and 4. Element 3, it goes with 4 and 2. Okay, so now let's move forward and write the matrix. So we're going to have the first matrix, which is going to be 200 minus 200 minus 200, 200. Remember, K1, it goes with 1 and 3. So it's going to be U1 and U3. Okay, and then now let's do K2 for element 2. So element 2, we have 400. So it's going to be 400 minus 400. Okay, minus 400 and then 400, like this. And then K2 goes with what? K2 goes with what? With 3 and 4. So we're gonna have the 3. We're also gonna have what? The 4 here. Okay, and then now let's do the 3, the element 3. So it's 600. So it's gonna be 600 minus 600, minus 600 here, and then 600, and then 3, it goes with what? With 4 and 2. So it's gonna be U4 and U2, like this. Okay, and then after here we're going to combine them, K1, K2, K3, and then to give what? To have what? The global stiffness. Remember, the first question wants us to determine what? The global stiffness. So it's gonna be the big letter K to show that we're doing what? The global stiffness. Remember, here when we're combining, we check how many nodals do we have. We have 1, 2, 3, 4. We have 4 nodals, which means we're going to have what? 4 matrix. We're going to have 4 by 4 matrix. Okay, guys, we're going to have 4 by 4 matrix. So it's going to be U1, U2, U3, and then U4. Okay, even this side we can write U1, U2, U3, and then U4. Yo, what am I writing? Like this. Okay, now we check. Wherever there's U1 and U1, we're just gonna add them. Okay, if we have U1 at first element, we're gonna add them. If we have U1 and U1 on second element, we're gonna add with the first one. So now let's check on the first element. Do you have U1 and U1? Remember, here it's gonna also be U1, U3. Okay, here it's gonna be U3, U4. Here it's gonna be U4, U2. I think I was supposed to write in a different color. It's gonna be U1, U2, U3, U4, then U4, U2, like this. Okay, so now we're going to check U1 and U1. Do you have U1 and U1? Yes, we do, which is what? Which is 200. Do we have U1 and U1 at element 2? No. Do we have it here? No. So which means we're going to write what? 200 at U1 and U1. Okay, and then we check U1 and U2. Do you have U1 and U2 here at first element? Yes, which is negative 200. And then on our second element, do you have it? No. On our third element, do we have it? No. So it's going to be what? Negative 200. And then we check, do you have U1 and U3? U1 and U3. You guys, here it's 3, not 2. It's 3. Okay, it's 3. Do you have which means I made mistake even here, because here it's 3, not 2. We have 200 here, and then here we have U3. Okay, so now U1 and U1, we have U1 and U1, which is 200. Do you have U1 and U2? Nope, we don't have U1 and U2, which means it's gonna be what? It's gonna be 0. So we have 0 here. Okay, and then do we have U1 and U3? Yes, we do have U1 and U3, which is what? Which is negative 200. Do you have U1 and U4? Nope, we don't have U1 and U4, so it's gonna be 0. Okay, and then now let's move forward to U2, U1. Do you have U1 and U2? We don't have it, so 0. Do we have U2 and U2? Do we have U2 and U2? Yes, we do, which is what? Which is 600. So we're gonna write 600 here. Do you have U2 and U3? Nope. Do we? No, we don't have, so it's gonna be 0. U2 and U4, we do have U2 and U4. U2 and U4, which is what? Negative 600. U2 and U4 is this one. So it's going to be what? A negative 600. Okay. And then let's come to U3. U3, U1. We do have U3, U1, which is negative 200. So we're going to write a negative 200 here. U3, U2. Do you have U3, U2? No, we don't have. So we have 0. U3 and U3. Yes, we do have U3 and U3, which is what? Which is 200. We also do have U3 and U3, which is what? 400. So we're going to have 200 plus what? Plus 400. So which means it's going to be what? A 600. Okay, guys, did you follow that? We have 2 U3s. We have this one and this one. So we're going to add them. 200 plus 400, which is what? Which is 600. It's this one. Okay, it's this one. And then U3, U4. Do we have U3, U4? Yes, we do. Which is what? Which is a negative 400. Okay, and then U4, U1. Do we have U4, U1? Nope. U4, U2. U4, U2. Which is what? Which is negative 600. This one. So we have a negative 600. U4, U3. Do we have U4, U3? U4, U3. U4, U3. Yes, is this one. We have a negative 400 here. Do we have U4, U4? Let's check. U4, U4. It's this one and this one. It's gonna be this part plus this part. 400 plus 600, which is 1,000. So guys, this is how we determine the global stiffness. This is your 5 marks or 10 marks. I don't still remember how much, but I think it was like 5 or 10 marks. So to get the global stiffness, this is what we do. We first determine the first element, second element, third element, and then we write them in a matrix form. After writing in a matrix form, we combine them, and then we call that what? A global stiffness. This is what? Global stiffness. Do you have any question, guys? Hello, guys, do you have any question? Okay, seems like you guys, you don't have any question, so let's move forward and then get the boundary condition. the boundary condition. When we're talking about the boundary condition, we're talking about node 1 is connected to the wall, and then node 2 is also connected to the wall, which means u1 is equals to 0 and also u2 is equals to 0. Okay, that's what we call it, the boundary condition. When we're talking about the boundary condition, we check which node is connected to the wall, and then if it's connected to the wall, which means it's going to be what? It's going to be 0. So node 1 and node 2, they're connected to the wall, which means u1 and u2 is what? It's 0. u1 and u2, it's 0. Okay, guys, did you follow that? Okay, moving forward, we're going to determine the boundary condition. After determining the boundary condition, that's where we're going to determine the equation. After getting the equation, we're going to determine the the nodal displacement. Okay, so boundary condition, BC is for boundary condition u1 is equals to 0 and u2 is equals to 0 because node 1 and node 2 are connected to the wall. Okay, now we have our boundary condition. We have u1 and u2, and then we also have forces. At node 4, we have the force. So we can write that matrix like this. Remember, we have the global stiffness. This is our global stiffness. So here at K, we can write forces. Here we can write the value of forces F1, F2, F3, F4, okay, so that we can determine what? The nodal displacement. So we're just gonna take this global stiffness, and then on the side we write F1, F2, F3, F4, and then if we have the value of that force, we're gonna substitute it. Okay, so now moving forward, we're going to write this boundary condition. After writing the boundary condition, we're going to introduce a global equation with the forces. So we're going to have F1, F2, F3, and then F4 like this. And then here we're going to write what? The value of what? Of global stiffness, which was 200, 0, negative 200, 0. So our, it was like this: 200, 0, negative 200, 0, 0, 600, 0, minus 600. And then we have a negative 200, 0, 600, minus 400. Okay, and then we have 0, minus 600, minus 400, and then 1,000. Okay, remember we have u1, u2, u3, and then u4. Okay, u4 like this. So remember, our u1 and u2 are equals to 0. This is 3 are equals to 0, which means this one is gonna be 0, and then this one is gonna be 0. Okay, and then the forces, let's see the forces that we have. So we have a force at node 4, which is 25 kilonewton. And remember, here at node 3, it's joined, K1 and K2, they're joined here. And remember, last time I said there where we have a node at 2, we said F2 plus F2 are equals to 0 because there's no what? There's no external force, which means our F3 is going to be 0, okay? Our F3 is going to be 0, right? And then moving forward, which means this F3 is going to be 0 because there's no force applied. And then at node 4, we have 25 kilonewtons. So F4 is equals to 25. And remember, U1 and U2 is what? It's 0, which means it makes everything here equals to 0. So here we have U1, U2, U3, and then U4. And then even this one's going to be 0. So it cancels everything. Okay, U1 and U2 like this. So which means we're gonna left with what? With the negative this is this. So we'll be left with this one. We're left with this 600 minus 400, 400, and this is minus 400, 1000. Okay, so the moment we have the boundary condition, we say U1 is 0 because it's connected to the wall. Even U2 is equals to 0, it's connected to the wall. So it cancelled everything. And then F3, we said there's no external force applied. So which results to what? To 0. And then F4, we are given that F4 is what? Is 25 kilonewton. So what we are left to is, it's F3 and F4, the values that we are left with is in this row, U3 and U4. So we're going to focus on U3 and U4 since the boundary condition says U1 and U2 are 0. Okay, let's move forward. We're going to have F3, which is equals to 0. Okay, and then F4, which is equals to 25 kilonewton. Okay, F4. Or equals to, remember we have the stiffness. Why am I writing this? We have the stiffness here. So we're left with U3 and U4, okay, because U1 and U2 are 0. So under U3 and U4, we are left with 600 minus 400, and then we have minus 400 and 1000 here. Okay, remember it's U3, U4, U4, and then from here we can determine the nodal displacement U3 and U4. So how are we going to determine that? We're going to write the equation. So remember F3 is equals to 0, so it's going to be 0 equals to 600 multiplied by U3, so it's going to be 600 U3, and then negative 400 times U4 is going to be minus 400 U4. Okay, and then F4 we have 25 kilonewtons, so it's going to be 25 multiplied by 10 to the power of 3 equals to negative 400 U3. Okay, and then plus 1000 U4 like this. Okay, now we have these two equations. So from here, that's where we can solve for U3 and U4 using what? Simultaneous equation. We're gonna solve for U3 and U4 you're gonna use simultaneous equation to get what? U3 and U4. So this U3 and U4, we call them nodal displacement. Nodal what? Displacement. So in the question, they will ask you number B, maybe because number A will ask us to determine the global stiffness. Number B will ask you determine the nodal nodal displacement at point 3 and 4. Okay, so at 3 and 4, at node 3 and 4, which means we're going to look for U3 and what? And U4. That's how we do it. And then number C, they say you have to determine the reaction forces at node 1 and node 2. So to determine the forces, guys, up here we're going to use simultaneous equation to get U3 and U4. You're gonna do that. Okay, and then the third question, they say we have to determine what? The reaction forces at node 1 and node 2. The reaction forces at node 1 and node 2. So what you're going to do, you're just going to take the first element. Where is it? Sorry. Where's that element? Oh, it's here. It's here. So here they say you have to determine the reaction at node 1. Let me read the question again. Yes, they say determine the reaction forces at node 1 and node 2. So you just come and take this matrix element 1 and the matrix element 2. So here on the left hand side, we're going to have F3 and then F4, and then here we have F1 and F2, and then you determine the value of F1 and F2. So to determine the value of F1 and F2 is going to be F1 is equals to 200 U1 minus 200 U3. And then remember, you've already calculated the value of U3, which means you're just going to substitute the value of U3, and then you know that U1 is what? It's 0. And then you get what? The reaction at F1. And then F2, you're still going to do the same. It's going to be negative 200 U1 plus 200 U3. You have the value of U3, you substitute, and then you get the value of F2. So that's how we get what? The reaction forces at node 1 and node 2. You just go back to your first element, focus on your first element, and then get F1 and F2. Okay, that's how we do it. Guys, do you have any question? Hello? Guys, do you have any question? Okay, you don't have any. So this one, you're gonna get the value of U3 and U4, and then on the example they get U3 as 250 divided by 11. How much? My calculator is far. Okay, they get U3 as 250 divided by 11, and then U4 as 375 divided by 11. So what I was saying, when they say you have to determine force 1, you're going to go back to your matrix, and then your matrix for element 1, it was 200, negative 200, negative 200, and 200, which is 1 and 3. Okay, it was 200, negative 200, so which means we're going to have F1 and F3, and then they want us to determine what? The force at node 1, so which means it's going to be 200 U1 minus 200 U3. Okay, and then we know that U1 is 0, so this one is going to be 0, and then our F1 is going to be what? Negative 200 U3, and then here we have already calculated the value of U3. Okay, you just substitute here and then get what? The value of F1. When they say determine the reaction at node 1 and node 2, you just went back to the matrix, and then you get F1, and then F2, you went to the second matrix, and then you do the same and substitute the value of the displacement that you get. Okay, guys, so that's what we do under this displacement method. You'll be given the spring, and then you split it. After splitting it, you do the matrix. After doing the matrix, you combine to get what? To get the global stiffness. Okay, after getting the global stiffness, the next question is going to be what? Determine the nodal displacement, the U1, U2, or U3, U4. And then remember, don't forget to check the boundary condition. Don't forget to check the boundary condition all the time. Okay, so if the nodes are connected to the wall, just know the node 1 or node 2 is going to be 0, or node 3 is going to be 0 if it's connected to the wall. Okay, guys, and then if you are given a parallel, a parallel spring, or spring in a parallel or in a series, let me say something like this. If you are given something like this, you can see that these two springs are parallel. Let's say here we have K2, and then here we have K1, and then let's say we have another spring here, and then we have a force. Okay, let's say force P, then let's say here is K3. Okay, and then let's say here we have another force moving to the left, F, like this, and then here let's say we're going to have 0.1. Okay, and then here let's say we're going to have node 2, and then here we're gonna have node 3, and then somewhere here we're going to have node 4. Okay, like this, which means we're going to have three elements, K1, K2, K3. So we're still gonna do the same thing, okay, even though they are in a parallel in a parallel. K1 and K2, they're in a parallel. They're parallel to each other. So what we're going to do, we're still gonna split it. Remember, this 3, it's in between this K2 and K1 and K3. Okay, so which means K1 is gonna move from 1 to 3, and then K2 is gonna move 2 to 3, and then K4 is gonna move from 2 to 4. Okay, so when we split it, it's gonna be like this. K1, it's 1 to 3. Okay, and then K2 is 2 to 3. Okay, and then K3 is gonna be what? 3 to 4, because this 3 join both. It joined both. So which means at K1 we're gonna have node 1 and node 3. At K2 we're gonna have node 2 and node 3. So K3 we're gonna have node 3 and node 4, and then you're still gonna do the same thing. Okay guys, even if we are given the system in this way, you still gonna do the same method that I showed you. Okay, step 1 you have to split it, and then step 2 you have to do the matrix. We still step 1 we split it, and then you do the matrix, and then step 2 you combine them, you add them together, and then get the global stiffness. And then number 2, when they say you have to determine the nodal, you introduce the forces and then substitute the values. After that, you determine the equation. Okay guys, I think we're gonna stop here. If you have any question, just text me in private or in the group, and then I will help you with that question. So now I'm going to do that question paper that someone sent in the group, and then I'll share the solution of it. Okay, and I'll also look for another the previous question paper where we have the stiffness. This is displacement method. I'll also look for other question paper and then solve it, and then I'll share in the group. Just feel free to ask any question. So yeah, we're gonna stop here. Are you okay guys? Okay, if you don't have any question, good night.